Hello, hello, hello! How's it going? Take two. Apologies that I was having a bit of a microphone issue earlier, and apologies that this intro is now not the same as it would normally be, but this has completely thrown me off. Welcome back. Today it is Monday, the 29th of December, and today I'm going to be doing a live solve of the ESAT, sort of the NSAA ENGAA 2017 stuff. I'm going to wait until someone joins so they can let me know if my audio is having issue again. I know I was having an issue earlier where my speaker was just not working, just throwing the biggest hissy fit. And it seems that my sound settings are like all changed. So it seems like it adjusted my default microphone, shifted that back, made sure the microphone was okay. So hopefully it should be okay now. Now I was saying, hope you all had a good Christmas. I went back home, saw the family for a bit. I'm like, semi-certain one of them may have given me that flu that's going around, but like I can tell I'm going to be sick in like 2 days time, which is the worst feeling. So I'm trying to take it a bit easier, trying to like keep my energy, take my vitamin C, and make sure it's like not too bad. But I know that like it's been going around, and that like a lot of you had it going into the. I mean, it's apparently it's massive. Oh, I will say now that someone is live, can you let me know if you can hear me? Let me know if I'm still having any audio issues. That'd be great. In the meantime, I'll keep sort of like filibustering and kind of give an update because I know this flu. Like I read up about it, and apparently it really is affecting like the teenagers more than it's affecting everyone else. So I was thinking I'm scot-free, that the virus had decided I was too old to come for. But so like I'm hoping it still does think that. So yeah, but I know a lot of you were like ill around the October cycle, and hopefully you guys stay fit and healthy and able to perform at your best. I also know I haven't been doing too much of the NSAA work or the ESAT work because that was more for the October cycle, and mostly TMUA stuff I've been doing for the January cycle because that's what most of my students have been doing. I also burned through quite a bit of the papers, but I think today, given that it's next week and given that I've had requests for it, I want to keep I want to do another run just to make sure I demonstrate any last minute technique and answer any final questions. So the plan is to do a live solve today and health dependent, just making sure I'm on good form and I wouldn't be just like hacking into a microphone the whole time. The plan is to do another live stream on Saturday with a bit more notice so people can show up and ask a few more questions. I've had requests for the kinds of question that come up in an ESAT. So I might do a bit of that, answer sort of any final questions there, and just make sure everyone is good and ready to sit that ESAT come next week. It's just amazing how quickly it hits you after Christmas. So you have your Christmas period, and it's like, oh, it is next week, and you have to kind of like get yourself really back in the motion of it all. So today I've got my NSAA 2017. I'm not going to do anything special, so I'm not going to do what I was doing before, answering the questions from the back where I knew they were the most difficult. Today, I'm going to be working from the front, sight unseen, as I would the real thing, and really demonstrate that exam technique. So, reminder of that, I use a multiple pass system, which means that the first pass, I'm going to be doing only the questions I know I can do quickly and accurately. If I think I can do it, but it will take too much time, I'm going to skip it, come back to it later. If I'm sort of on the fence about whether I can do it, skip it, come back to it later. I'm going to keep a log of which questions I haven't answered, so I can come back to them in the second pass. I'm also going to take split times so I can see if anything comes out in the sort of analysis of that. As always, do let me know if, also thank you to the person who told me that I was having sound issues last time. I'll be keeping one eye on the chat, so do let me know if anything else happens, then you can kind of bring that to my attention. In the meantime, let me get you guys put over there. I will start sharing my screen so that we can get into it. Answers. We don't start with the answers. No. If only. All right. So starting with Math 1, then moving to Math 2. Actually, let me explain a little bit of that. So a reminder of where I'm pulling my questions from. Because they fused the NSAA and the ENGAA, I'm going to do what my recommendation is for the pre-2020 paper, actually for all of the papers. which is that Math 1 and Physics I will be doing from NSAA because the questions are separated and there are more of them. And for the Math 2, I'm going to be using the ENGAA questions because there are more of those than there are in the NSAA. Slightly more of you join now, so I will keep an eye on the chat in case anything comes up tech-wise. In the meantime, let me go through and see what there is. So I've got my timer at the ready. Got everything. Oop, shouldn't have zoomed in there. Apologies. All right, everything at the ready. And let's go. Right, so here, let's square that out. So it's going to be, so for question 1, it's going to be square the first, square the last, and twice the middle 2. Root 36 is 6, so I'll make that 12. Over... God damn it. You are right. You cannot see my screen. You see, this is why you guys... There we go. All right, let me start the clock again. Let me reset. Let me just reset the whole thing. I am not having a good tech day. And this is how you know. I can tell the cold's coming through because I'm not on top tech form. Thanks for letting me guys know. This is going to go so well. I can feel it. All right. TMUA paper 1. TMUA paper 1, I'm not going to solve that as a live solve because that's not where they're drawing the ESAT questions from. You can absolutely do TMUA paper 1 questions in preparation, though, for Math 2. Absolutely. Right, so let's start the clock again, and let's go. Right, question 1. So, in fact, a little too zoomed in. Quite right about those ECAAs. So we're going to square this out. Square the first, square the last, twice the middle 2 root 36. Root 36 is 6. That makes it 12. All over square the first, square the last, minus, and again, twice the middle 2. That is 6. That makes that 12. That cancels with that to make it 3. So it ends up being 24, 27 over 3, which is 9, which is F. Sweet. Lap time. Next. Solve this inequality. Quadratic inequalities. Nice and easy. You just move everything to one side. Nope. Let me erase that. Move everything to one side. So plus x minus 15, bigger than or equal to 0. 30 is going to make that 2x x. So I want it to be plus 6 minus 5. So that's my minus 5. That's my plus 6, bigger than or equal to 0. I'm going to sketch it out. So x is going to be at 5 over 2 and minus 3. And I want it to be bigger than or equal to 0, so I want those two. So x is less than or equal to 3, bigger than or equal to 2.5. The answer is E. Right, split time. Next. So is it that ESAT questions are the exact same as NSAA? Yes. If you look at the sample paper, that's where they're pulling from. So that's what I'm going to do today. So the sample paper is just pulled from here. So this equation gives y in terms of x, rearranged to make x the subject. So it's going to be y plus 5 over 3 is x over 2 minus 1 squared. Let's plus minus square root both sides. Let's add 1 across. Let's multiply by 2. Y plus 5 over 3. So that should be equal to x. And that, so 2 plus or minus 2 root y plus 5 over 3, making sure I actually select the right answer because I've made that mistake in the past. Question 4. Okay, so apples are x, pears are y. 2 apples and 5 pears is p. 3 apples and 2 pears is q. I want to find an expression for y. So let's eliminate x. So from this one, 2x is equal to p minus 5y. X, in fact, no. If we're eliminating x, I'm going to triple up the first one. I'm going to use the proper elimination method. So what that means is 6x plus 15y equals 3p, and 6x plus 4y is equal to 2q. And if I subtract them, that obviously gives me 0. That minus that is 11y. That minus that is 3p minus 2q. So y is equal to 3p minus 2q over 11. 3p minus 2q over 11 is g. Lock it in. Let's go. Okay, so here, 5. P is directly proportional to q squared. Q is inversely proportional to R. So if I put that in here, that is A2 squared over R squared. In other words, P is inversely proportional to R squared. So P is equal to C over R squared. So because Q is inversely proportional to R, no, P is directly proportional to Q squared. And I'm going to link these up so they're the same. If I double Q, I half R because they're inversely proportional. So when Q equals 4, R is equal to 2.5. So that means that when P is equal to 2, R is equal to 2.5. So 2 is equal to C over 5 over 2 squared. This is not the most efficient. I should have just calculated both constants, but I'm in for a penny, in for a pound. So that is going to be 4c over 25 is equal to that. So 2 cancel for 2. So c is 25 over 2. And p is equal to 25 over 2r squared, where the r squared is on the bottom. So that it looks like E. Okay. Yeah, that was probably not great on the split, but I'll look at that afterwards. Right, 6. 2 sequences defined by the following. Nth term is that in S. Nth term is that in T. What is the smallest value for which the nth term of S is greater than the nth term of T? Well, that means that thing has to be bigger than this thing, and we get another quadratic inequality. So n squared plus 7n minus 98. 98 is 7 times 14, which differ by 7. So n plus 14, n minus 7, bigger than 0. So we have n 7 minus 14, bigger than 0. N has to be bigger than 7, so it cannot be equal to 7. So it is 8, which is C. Okay. Timing tips. I will absolutely give you that at the end. Don't worry. So 7. Which of the following is a simplification of that? Let's get that over the same denominator. So 2x cubed into 2 minus 3x minus x squared into 9x squared minus 4. All of that is going to be over x cubed into 2 minus 3x. So simplifying the top, we have 4x cubed minus 6x4 minus 9x4 plus 4x squared, not making a sign error, all over x cubed. Let's keep this factorized in case things cancel. So that gives me minus 15x4 plus 4x cubed plus 4x squared, all over x cubed 2 minus 3x. Let's cancel some stuff. So we can take an x squared out of that. We get minus 15x squared plus 4x plus 4 over x cubed 2 minus 3x. Cancels. How do you simplify? Do you simplify? 60 is 6 and 10. So I think that's going to be... Okay, I'm going to have to split this out, do it long form. Man, this is taking too much time. So that's plus 10x minus 6x plus 4, which then I factorize out a 5x from that, and I get a 2 minus 3x. And I take out a plus 2 into 2 minus 3x. So it's 5x plus 2 into 2 minus 3x all over x into 2 minus 3x. when those cancel, so it is 5 plus 2 over x, which is d. Lock that in. Took too long on that. Not good timing. All right, I'll just have to, well, I built some time anyway. So parallelogram labeled clockwise, O, P, Q, is in the first quadrant. Cool, that's the origin. Cool, that's X, that's Y. O, P, Q, R. R, sorry, labeled clockwise. O, P, Q, R. So R is at 3a over 2. This is at 2a and a plus 1. This has gone over half a, so this has also gone over half a. So that is at a over 2 and a plus 1. Those are the coordinates of P. The area is 9 units. I think area is base times perpendicular height. So 9 is equal to 3a over 2 times the perpendicular height of a plus 1. What are the coordinates of P? So I'll have to bear that in mind, that I have to go back and find those coordinates once I found it. 18 is equal to 3a squared plus 3a divided all by 3, a squared plus a minus 6, a plus 3, a minus 2. So a equals 2 because it has to be positive, and that makes 1, 3 the coordinates, which are B. Cool. Next. 9. What is the value of x? I have to zoom in so you can see it. Makes the following expression correct. All right, let's get everything in terms of powers of 2. So that's 2 to the 3 plus 2x times 2 to the 2x times 2 to the minus 3x, which is equal to 2 to the 5 over 2. So that implies that, add all the powers together, we get plus 4x minus 3x. So 3 plus x equals 5 over 2. X equals minus a half, which is D. Okay. Let's zoom out a little bit. So for 10, there are 100 students in year 10. Each studies exactly 1. Okay, this looks like a two-way table. So French, German, Spanish, boys, girls, and we can get our totals. X girls study French. 3X girls are in total. 2Y boys study German. There are 35 students studying Spanish, of which Y are boys. So that becomes 35 minus Y, which is an expression for the total number of students studying German. Well, this is, this total is 2x. So that's 2x plus Y minus 35. And then the total here is 2x plus 3y minus 35. 2x plus 3y minus 35 is F. Lock that in. Okay, 11. Love interior and exterior angles. Right. So an exterior angle is 180 minus the interior angle. Sorry. No, that's even easier. Exterior angle is just 360 over n. So 360 over n is 4 degrees larger than 360 over n plus 3. We just solve this for n. Let's get this to a common denominator. So 4n plus 12 plus that, which is 372 over n plus 3 is 360 over n. Let's cross multiply. 360n plus 1080 is 4n squared. Don't you dare. Probably haven't done this right. No, I have. Whatever. Okay, so 0. Okay, so this is probably divide by 4. I'll do that later. So 0 equals 4n squared plus 12n minus 1080. So 0 equals n squared plus 3n minus. Now let's divide this by 4. We get 2, carry 2, 270, which is 27 and 10. So 27 and 10, drag a 3 across to make it 9 and 30. No. Difference. 3. Oh, drag a 2 across to make it 18 and 15. There we go. Okay, so that's n plus 18, n minus 15. So given that n has to be positive, n is equal to 15, which is C. Lock that in. Ooh, I'll explain how I did that. Finding the factorizing. Okay, so 12. A ship is on a bearing of 220, which makes that angle in there 40. Let's see, draw that a bit bigger. Bearing of ship R from a lighthouse L. C is north of R and the same distance from the lighthouse, so it's going to be some sort of isosceles triangle business like that. And if that's 40, then that's 40 because they're both north and angles in parallel lines, which makes that 40. The bearing of L from C is this angle here. Well, this angle here is 100 to make up 180. So that's 80 there, which is the answer, which is B. Apologies, the diagram isn't bigger. I'll go through that later. 13. The hands of a 12-hour analog clock move continuously. When the time on the clock is 4, the angle is 120 at 4:40. Well, okay, let's think about this. Because it was there, which was 120. It is now at that and that, where that is 40, so it would be 120, but it's 120 minus the angle that this thing has moved through, and it's moved through 2/3 of an hour, and 1 hour is 30 degrees, because it's 360 over 12, making that 10. So I think it's 100 degrees, which is B, because 40 minutes is 2/3 of an hour. 360 over 12 is 30 degrees, and 2/3 of that is 20 degrees. So it's moved 20 degrees forward, so it's closer. So yes. Cool. Timing, I'm feeling, I don't know, at least I'm getting them right. Or at least I feel like I'm getting them right. So the cost of a manufacturer is, so the cost is directly proportional to the volume. The baker makes a 70% profit when he sells a large rectangular cake. So the cost, so the price of it is 1.7 times the cost. The baker sells a large rectangular cake, so 680 is 1.7 C, and that looks like, so 4. The cost is 4 for a large cake. So smaller rectangular cakes, the length, width, and height are half, so the volume is 1/8. So the cost is 1/8. So the cost of a small is 1/8 of that, which is 50p, so 0.5 pounds. He sells a 6-pack of the smaller cakes for 650. So 6 of those, the cost of that is 3 pounds. The profit is 350, which is D. Okay. 15. Forgot how fast you have to go. Right. So there are 4 female rabbits. So female to male. We have 4 female to X male. Customer buys 2 of the rabbits chosen at random, and each rabbit is equally likely to be chosen. Both rabbits are male. So that would be X over X plus 4. And then there are X minus 1 males left out of X plus 3 total. And that is 1/3. And we got to solve for X. Sweet. So that means X squared minus X over X squared plus 7X plus 12 is 1/3, which means that 3X squared minus 3X is equal to X squared plus 7X plus 12. Move it all over to X squared minus 10X minus 12 is 0. Divide by 2. Let me check. You can see it. You can. Right. So that's going to be minus 6 plus 1. You can't have minus 1, so X is equal to 6, which is C. Lock it in. Just keep the intensity. I feel like I'm making good pace, not overworking it, not underworking it. 16. Diagram shows a square, side length x. A circle is drawn which lies at the midpoint of one of the squares. So that's the radius. This side forms part of the diameter with the circle. The circle passes through two corners of the square. Yep. What's the area? Square of side length x. So if that is x, well, that is x, and that is x over 2. So that is a scaled up 1 to... No, that would be root 5. And then we divide it all by half. So that's root 5 over 2x is the radius. So the shaded part of the semicircle is the area. So it would be a half of pi times r squared minus the area of the square, which is x squared. And then let's simplify this. So it would be 5 pi over 8 minus 1 lots of x squared, which is 5 pi minus 8 over 8 lots of x squared, which is f. So I'll lock that in. 17. Hollow pipe is 16 centimeters long. I'm not going to get confused between radius and diameter. Okay. So external diameter of 10, internal of 8. Density is that. What's the mass? Mass is the volume. What's the volume? Volume is outer big minus small. So V big minus V small. So that's a third pi. Outer radius is 5. No, not third. No, it's just pi r squared h. What am I talking about? This isn't a cylinder. It's not a cone. So it's just pi r squared h minus pi r squared h. So that is the volume. And the density is 8. So the mass is just all of this times 8. So it is pi, well, 8 pi, well, 64, so take a 16 out as well. So that's 8 times 8, 64 times 2 is 128. Into 25 minus 16, which is 9. And oh, there are more answers. Great. So what is 9 times 128? 128 times 9 is going to be a bigger number than 900, and it's going to end in a 2, so it must be G. Let's not waste time calculating that. 18. Well, I feel like I've got my... Oh, no, that's right. No, I've definitely got my splits off, but whatever, it's fine. I must have forgotten to take one. So the distance between two opposite sides of a regular hexagon is 12. So I know a regular hexagon is going to be made up of 6 equilateral triangles. And the distance between two opposite sides is, so that becomes 6. And I know that's 30, 60, 90 triangle. So I know, find the area of the regular hexagon. So I know this is based on a 1, 2, root 3, but now it's scaled up such that one of those have a height of 6. So I've multiplied by root 3 and by 2. So that becomes, well, it almost doesn't matter. So that's 2 root 3 and 4 root 3. Now the area of one of these is a half base times height. So it's a half of the base, which is root 3 times the height, which is 6. So 6 root 3 for one of these, and there are 12 of those, so it makes it 72 root 3, which is E. Okay. Oh, it's done. Oh, I'll stop the clock. So that was done in sort of 22 minutes and 30, when I think I had... Oh, actually, I should have really calculated that before I start. So if it was 18 questions... so 18 questions at 1.5 minutes per question, 27 minutes. Oh, that was well ahead of time. Boom. Okay. I feel good about that. Whew. So realistically, in fact, I should really have checked that I actually have answers for everything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 answers submitted, which is good. Let's check them and see how I did. All right, so F, E, B, G, E, C, B. No, B. D, sorry, D for 7, good. B for 8, good. D for 9, good. 10 is F, 11 is C, 12 is B, 13 is B, 14 is D, 15 is C, 16 is F, 17 is G, 18 is E. Perfect. All right, let me see how my splits were. If there was anything that took too long. So it looks like question 7 took me too long. Let me go back to the question and just see what happened here. Yeah, that was just a lot of steps. It was just a lot of steps. Maybe it would have been good to tactically skip that because I knew I could do it, but could I do it quickly? That was a little more up in the air. So that question took too long. There are a few sort of 11 and 12 seem to take too long. You can cancel a lot of things immediately. Did I not see that? Oh, you're absolutely right. See, if you do it right, you always get it done under. I knew I was missing a trick. So yeah, let's go through a bit more slowly and see what I could have done under sort of better conditions. So you're quite right about that. What the ideal solution path there would have been. It could have realized I could have canceled that immediately. And that's difference of 2 squares. So I should have immediately seen 3x minus 2, 3x plus 2. Which cancels with that to make a -1, which turns that into a plus. So it would have been 2 plus 3x plus 2 over x, which is much simpler. Plus 3x plus 2 over x, which is 5x plus 2 over x, which again is d. So that's how you could have got d a lot faster. Thank you for that. Exactly. Yeah. So, okay, what's the lesson to myself then? I should have, with any algebraic fractions, you should always fully factorize and then cancel before dealing with them. It's just a bit silly that I didn't do that. So apologize for that. I'm going to go through, calm myself down, and with a bit more time on my hands, see if I can find, again, good solution paths or explain anything that I did that was a bit weird. Like one of those factorizations was weird. Want to give you that technique. But I'm not going to go through everything, so I'll do just the highlights. This was standard. This was standard. Just make sure you know how to do your quadratic inequalities. They really come up. Always sketch them so you know. This was standard. This was standard. Yeah, just going through the process of elimination of x. I liked how I did 5 because I think for me personally, going through the motions of finding the k for this, putting this all together, finding the k for this, putting this all together, and then combining the two would have been too much. So in situations like this, I like making the term you want to eliminate, in this case q, the same. So in order to do that, I need to double q. And because they're inversely proportional, that means I'm halving r to get to 2.5. So that's how I was able to get to p equal, because then when p equals 2, q is 4, and when q is 4, r is 2.5. So when p is 2, r is 2.5. And by putting the general relationships together, I knew that p was inversely proportional to r squared, plugged in the values, found c in 1 step as opposed to 2 steps, saved myself a lot of time. This was another standard quadratic inequality. This we've been through. I should have canceled. Always shout out, by the way, if you notice a technique that I missed, because it's good to have them all to hand. This, I think, self-explanatory. If you know that the area of a parallelogram is base times perpendicular height. If you don't, that's going to have been difficult. 9 was just power laws. 10, two-way table, probably not the clearest. But hopefully that made sense. You just kind of go through, nothing too rambunctious there. Again, this I could have divided by 4 right from the outset. So there I could have made my life easy if I'd said it was divided by 4 straight away. It still wouldn't have been the most fun in the world, but I could have done this. And then cross-multiplied. Yeah, that would have been easier. Okay. So it would have been easier than dividing by 4 on 1080. So I could have recognized that, so it's good to know. And it's always good, even if you get 100% on a paper well ahead of time, it is good to go through and just check on your techniques, because that does not mean the next one is going to be that good. Now, showing you this one in slow motion. Here's what I did. So draw my north arrow. So this is from L, so that means that's where the north arrow goes. 270 round clockwise means I've got that 40 down there. In fact, let me make this really big so that when I draw a north to there, which is then equidistant to there, that is also, so that is R. That is also north. So these are parallel lines, and that makes these Z angles, which makes that 40. And because this is isosceles, that is also 40, leaving me with 100 degrees left to bring it up to 180, which leaves me with 80 degrees left to make that a straight line from C. And because it's from C, that is where the north arrow goes. So that is 80 degrees clockwise from there. So hopefully that makes good sense. C, sorry, by which I mean 13, I think, wow, what am I doing? No. Let's race. What do you think about Churchill College for PhysNatSci? Honestly, I think they're all good for PhysNatSci. Churchill. No, there's not really much of a difference between the colleges. I'm going to be really honest when it comes to the individual courses. So with college choice, I just say like wherever you feel most at home, because you're going to be living there for 3 or 4 years. And if you're not in a place that you like, that you're well suited for, it feels like you're just living at the office. So the biggest thing is, do you like Churchill? Doesn't matter what I think about it. Timing tips now. Go on, I'll go through timing tips now. So my recommendation for timing. So I was extremely lucky in that I had a very, very good math teacher when I was 10 years old. And she made us do what was called turbo quizzes. This was at the time when we were learning how to do fractions and like simplifying the fractions. And so she gave us a tiny little piece of paper which had 5 fractions on it. And it was our job to, hold on, story time. No one's looking at that. So we had this piece of paper with 5 fractions on it, and we had to simplify them and convert them to a decimal. And we had 1 minute in which to do it. So that was my first test of like speed math. And if our score started getting too high, she would knock 5 seconds off. So then, oh great, 55 then, 50 then. And it was a really good lesson that you can choose to make math difficult for yourself by doing it really quickly. And doing it really quickly is a good way to induce execution errors that you would not make if you had the time to go slower. So I'm lucky I had that at the very young age. And I built that all the way through my sort of GCSEs and A-levels. What I would recommend, if you really want to get a taste for it, is doing AS math papers. Well, it depends. If you're only doing Math 1, I would recommend doing GCSE non-calculator papers as fast as humanly possible, because there's plenty of those to go for. The Edexcel GCSE, not the iGCSE, or just any syllabus which has non-calc papers, speed run those. So you should be aiming to do them in less than half time is a good rule. So for a GCSE paper, and then for Math 2, I would recommend doing the same thing with an AS paper. Obviously, some of those questions require calculator. You can kind of skip those or kind of get up to the point where you require typing in a calculator thing. And again, speed run it. Keep a little sheet. log your times and see if you can get faster and faster and faster. Almost like the omelet challenge on Saturday morning breakfast. Like, just how fast can you do it? So that's actually something I'm planning on doing in the summer when we get back onto the admission cycle, is to demonstrate some of those speed runs to get you up on like how to train those skills. But that, just anything where the math is at the standard of the math 1 or the math 2, speed run it. And you can work that muscle in isolation with math of like the appropriate difficulty without burning through past papers for like the NSAA or the ENGAA. And if you don't like that, if you want to start a bit smaller, you can train yourself up on even that turbo quiz idea, right? So you can go, I've trained some students on this. Go to an exercise in your textbook, look at a single line of one of those questions where it's like 1A through K, and just pick 5 of them and then do them as fast as humanly possible. Then you think, all right, what went right, what went wrong? Then sprint again on the next one. So if you're going to do short sprints, no more than a minute, just so you can practice getting into that gear, getting out again, and analyzing your sort of internal feedback. So there's a lot you can do. You have a lot of resource available to you to practice that sprint skill in isolation. And one more thing, if you're going to be working your speed work, you want that to be your entire focus. Why that's important is you should be practicing that on content that conceptually is very easy for you, so that you don't have to worry about solving the question. You can just get a sense of the internal cogs turning and get that kind of good internal feedback. So that is how I think you can develop speed. How close is the ENGAA and NSAA to the actual ESAT? In theory, they should be identical. They were 2 separate papers that they have merged into the ESAT. And if you look at the sample ESAT on the UAT website, they are copied and pasted from the NSAA ENGAA. And the NSAA/ENGAA were themselves basically identical papers. I can show you if you want that the questions are just copy pasted across. So they are much more similar than the old PAT is to the new PAT. So they are very good practice, or at least they should be. I think Solomon Press C1 papers in 10 to 15 minutes is good for the ESAT. I remember Solomon papers. C1 papers, yeah. 10 to 15 minutes is fast. I remember, I thought C1 papers were longer than that. I thought C1 papers were like at least an hour. But yeah, that's the basic idea. Find any relevant math and do it as fast as humanly possible. Someone saying, my interview went really well, but on the college website, they said they haven't accepted anyone without further math in years, and I don't take further math. They said it's mandatory if your college offers, but I got... We'll see. We'll see. If they didn't think they could give you an offer, they shouldn't have given you an interview, is my opinion. But as with the entire process, it may be that... actually, it is definitely impossible to do... Because what you would do with NatSci without further math is you would take the math, especially if you're going for PhysNatSci, you would take Math A as your math module. They would walk you through all of the further math content that you need. So it actually shouldn't disparage you too much. Disparage is not the right word there, but it shouldn't disadvantage you. So on paper, I wouldn't say it's a disqualifier. But if they decide not to give you an offer, remind yourself that it just means that the process would not have been appropriate for your learning style. You've gone for it. You know the university you got into is the best you were going to get into, so you can feel like 100% certain that you're on the best possible path. So I wouldn't worry about it too much. When January rolls around, we'll see how the dice fall. How long should we take on TMUA papers? It depends. If you're talking about TMUA papers for their own sake, I would just stick to the 75 minutes because the timing is entirely different. Like ESAT is a full sprint. TMUA, you need to stop and take some time to think, and you can watch my live solves to get a sense of that. But yeah. The main one is 75 minutes, and I would take all of that. I wouldn't use TMUA to train yourself up for the ESAT necessarily. If you wanted to do TMUA paper 1 stuff to get ready for Math 2, then don't necessarily do it to a timer, but do it at full sprint just to get used to that feeling. What about the timing for each question? How long to spend on each? When to know how to skip? That sort of thing. 90 seconds a question. I would say you get a feel for it. So you'll see in my commentary, I'm like, this one feels like it's taking too long. And I looked at the timing and it was right. That was the one that took like 2 minutes 15. I would say have your checkpoints. So if you know your paper is going to be 20 questions long, you should know exactly how long each of them take. So if you know what your 5 minute, your 5 question checkpoint should be, know what your 10 question checkpoint should be, know what your 15 question checkpoint should be, and you have a timer in the top right, so you can track your stats and just make sure that's all going to plan. How long should we take on CMUA papers? What about the timing? So yeah, 90 seconds a question. You get used to the pacing. And that's why I would sort of recommend, if you're doing a run of one of these papers, take split times. So I can go through and I can show you what my actual split time is for every single question. And that will give you a sense of whether you're taking too long or not. So in the first pass, you should be doing 90 seconds a question. Every question you do should come in under 90 seconds and ideally be correct. Then in your second pass, your questions are allowed to take a little bit longer, because after you've done the first pass, you've done the first question, you've set the tone, you've only done questions that are giving you confidence and momentum. By the time you come around to the second pass, you've built up a time bank so you can spend a bit more on those questions. So it's making sure all of your time is being spent in the best way. What you don't want is to spend like 5 minutes on the first question, get an answer that isn't in the multiple choice. You feel the entire paper has gone terribly already. You're on the back foot. It's awful. That's why you do multiple passes. So work on that technique. Advice on how to reduce silly mistakes in the ESAT. Like I'm doing papers and I'm telling myself, I know there's a trap here, and I end up falling for it anyway. Classic. I would say speed work for that. So if you do your papers like at max speed, the point is to induce execution errors so you know them and then you can work on them so you spot them in future. You notice I did that here. I was like, oh, I've fallen for this before, so I'm not going to do that. I'm not going to get confused between diameter and radius. The way you learn from the mistakes is to make all of the mistakes so that you make them in practice and not in the real thing. So just get familiar with them. Cool. All right, let me go back into this. So that was a bit of a deviation. Let's go back to this, and I want to see if there's anything I need to explain further. So I was about to explain question 13, where again, they do like this style of question in these papers, where the trick here is to know how the hour hand moves. So in 12 hours, it obviously travels 180. So 12 hours, hold on, let me make that thinner. So 12 hours is equal to 360 degrees. So 1 hour is 30 degrees. And in this case, it is 40 minutes, which is 2/3 of an hour, which is 20 degrees. And it has moved on 20 degrees from where it was. So it was at 120 then it would have been at 120, except it has moved forward another 20 degrees, which means there's 100 degrees between the hands now. So not too bad. This, I think I explained okay, but quickly, because the trick here that I skipped the step on is this bit. So this is to do with the length area volume ratios. So if the length is a 1:2, then the volume is a 1:8. So it is 1/8 of the volume of the large cake. And because the cost is proportional to volume, it means the cost is 1/8 of the cost of a large cake, which means 50p per cake times 6 makes it £3 for the total cost. So the profit is 350. 15, this is one to get good at, like really good at. If you are going for the ESAT stuff. I will also say here on the topic of execution errors, you should know which ones you like to make. For me, I know I am the king of sign errors. So whenever I see minus signs, I'm like, not going to fall for it. Not today. It's not going to happen. And so things like multiplying by negative numbers or moving things around an equal sign, just sort of know that they're coming. and kind of, yeah, work around that. Gotta make sure to do A-level math, further math walkthroughs to get more subs because you definitely deserve it. Thank you. Realistically, it's my fault for not promoting myself better. I think I work on sort of dual cycles. So this is very much the admission cycle. And once we start heading into the summer cycle, which everyone does, then you don't worry. I'm going to be getting into the A-level math and IB math because holy hell, guys, if you have not seen, if you're doing further math, if you have not seen IB higher level AA math paper 3, have a look. It is wild. Like, it is the hardest paper I've ever seen anyone have to do ever at this level. And I find it so much fun. So especially if you're going for like pure math, oh, it is fun. So I'm going to do some live solves of that and definitely some like A-level math and physics papers. Right. So here, question 16. This is a classics technique of using a scaling triangle. So I knew it would be scaled up from like a 1, 2, root 5. So divide all the side lengths by 2 and then multiply by x. And that got me my root 5 over 2x as being the radius of the circle, which then I was able to plug in square very easily. Half pi r squared minus x squared. Nailed it. 17 was fairly self-explanatory. 18, they love to ask about regular hexagons. They are made up of 6 equilateral triangles, and they're a good test of your 30, 60, 90 triangles. So I knew my 30, 60, 90, my 1, 2, root 3, and I was scaling it up, so that was 6. Multiplied all by root 3 to get to 3, double it up again to get to 6. So 2 root 3 is my scale factor, got these side lengths. Each one of these small triangles then was 6 root 3, and there were 12 of those to get me to E. And that was it. All right, so let me go over here. Actually, let me show you, because some people were asking about whether these were good. Let's have a look at the ENGAA for exactly the same year. Question 1, identical. And they do alternating physics and math. So this was identical. This is identical. This is identical. Like, the questions are copy paste. Do you think it's worth doing the NSAA ENGAA papers multiple times? If you can't remember the question. I am the sort of person who does remember questions. So then it may not be worth it. It could be worth it because of what I was saying again, like if conceptually easy stuff you can use your speed work on. So it could be worth it if you want to make sure you're like aware of the traps and the execution errors. There could be some utility. You know your brain better than anyone else. You're probably not going to get the same utility as a pure live solve, but it could be helpful. You already did them all a couple of weeks ago. Don't blame you. Yeah, there's not that many, and they don't seem to be releasing new ones. So they haven't released last year's paper. They haven't released the October cohort. And I'm not sure they're ever going to release them ever again, which is so frustrating because I don't know how you're supposed to prep. But that's why I would say have a go. If you're really looking for stuff to do, especially math at speed, have a go at those GCSE math papers at race pace. Have a go at your AS math papers at race pace, and it's a good way of testing like the same syllabus material as fast as you can. I think past 2020 NSAA, they're more different, but still very similar. True. For past 2020, you need to use the ENGAA for any math too, because they got rid of that in the NSAA. But yeah. Yeah, the ESAT works as a massive question bank. In an exam, everyone gets different questions, so they can't release them. I know, but still, it's annoying because there aren't that many years for you to train on. Like, you only have a few bites of the apple, and you never feel like you've done them like enough preparation. Like with the A levels, you can do like papers going back forever, whereas with this, it just feels like you don't get enough. Exactly. Release some of the questions. Like, you can release what the question bank was from last year. Like, you're not going to recycle the questions unless you're feeling lazy. Like, people who've done the questions, they will be released online somewhere. Yeah. No, what no papers to do? I would just, practice your speed work. Practice your speed work. GCSE math, AS math at race pace. Right. So, okay, let me move down. Let's move into the math 2. I'm going to reset the clock. And excuse me, I'm going to be a little less proactive with chat in that time. So I hope you forgive. But in the meantime, it is time for Math 2. What about SMC? Senior Math Challenge. Heard that was good. Thoughts on that? No. I mean, maybe some of the earlier questions might be good for some of the math stuff, but that's honestly, I would suggest that more for people doing TMUA than the ESAT, because it's more about your problem solving ability. It's always a bit of fun, but I wouldn't use that as ESAT prep. Right. Math 2 time. Ready and go. So question 29. I'm seeing 3 minus. Okay. So that is 1 minus. Now that is 3 plus root 3 all over 2 into 3 minus root 3 squared. So it is 1 minus a quarter into, let's rationalize this first. 3 plus root 3, 3 plus root 3 all over 3 minus root 3, 3 plus root 3. Come on, Miro, you can do it. Oh my God. 1, come on, minus a quarter. So damn it, Miro. Square the first, square the last twice the middle, 2, and that becomes 9 minus 3, which is 6, and then you square it, so it's 1 minus a quarter into 12 plus 6, so that's 2 plus root 3 squared, which is 1 minus a quarter of square the first, square the last twice the middle, 2. So 1 minus a quarter of 7 plus 4 root 3, which is what did you do? Minus 3 over 4 minus root 3, which is equal. Next. Have to skip the physics. Okay. So we have this here, 31. So we have 2 sine x plus 1. I'm using s as a nice abbreviation, equals 0. So sine is minus a half. So sine is minus a half. So we'll cast diagram. So sine a half, 1, 2, root 3. That would be 30 degrees. So 30, but it's minus. So it's going to be, especially from 0. So that's going to be what, 210 and 330 are the ones I'm looking for there. We have cos of 2x is a half. Well, cos, that would mean that 2x is equal to 60 or 300. So x would be equal to 30 or 150. Or let's do the next one because I don't have both yet. So it would be 60 plus 360 is 420, which becomes 210. These are now the same. So k is equal to 210. And we have 1, 2, 3 before that. And that's the first one there. There's 3, so that's C. Okay. Which of the following? So we have this guy. Let me zoom in so you can see the powers. So what do we got? We got 3 into 3x squared minus 6 into 3 to the x equals 0. So that's 3 into 3 to the x into 3 to the x minus 2 is 0. This is never 0. This is never 0. So 3 to the x equals 2. And let's take, so x is equal to log to base 3 of 2, which is b. Okay. Here, right, I'm just going to have to do it and then see the answers at the end. 35. Keyhole consisting of straight lines and an arc and a circle, P, Q, and those are both 18. That is pi over 6. The longer arc, okay, so that is 11 pi over 6. And that, so r theta is 22 pi. And theta is 11 pi over 6. R equals 22 pi, cancels, 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 cancels for 2. R is equal to 12, so that is 12. So OS is equal to 30. So that area is a half AB be sine c. Sine of pi over 6 is a half. So it is 30 squared over 2 squared, which is 15 squared, which is 225, is that. And the area of the sector is a half r squared theta. R squared, and theta was, again, 11 pi over 6. So again, that makes it 12 down there, which cancels for that. So it's 12 times 11 pi, which is 132 pi. So the area should be 225, 132 pi plus 225 is C. Cool. Okay, 37. It is given that y equals, so y is equal to 2 to the 3p, and z is equal to 2 to the minus 2q. So y cubed is 2 to the 9p. Z squared is 2 to the minus 4q. Y cubed over z squared is 2 to the 9p plus 4q. Log 2 of that is 9p plus 4q, which is f. Okay. 39. The graph of the function, that has a local minimum. So we know y prime is 3x squared and 2px, and q is 0 when x equals 2. So 0, and then plug in 2 for that is 4 to 12 plus 4p plus q. Cool. And a local minimum when x equals 4. So plug in x equals 4. So 0 equals 1648, 68, 8p plus q. What are the values of p and q? Okay, well, let's double that up to give 24 and 8p and 2q. And I'll do top minus bottom. So 0 equals, that minus that is 24, that minus that is 0, that minus that is minus q. So q equals 24. And from that, therefore, 4p equals minus 36. So p is minus 9. So minus 9 and 24 is D. Cool. Next. 41. Look, come on. I'll get to any comments afterwards. So 41. Triangle. Q, 60, P, 4x, R, 8 minus 3x. Area is a half A, B, sine 60 is root 3 over 2. So it's root 3 over 4 into 4x cancels to make root 3x, 8 minus 3x. Maximum value of the area. Well, let's first, so that is 8 root 3x minus 3 root 3x squared. Differentiate that, and you get 8 root 3 minus 6 root 3x, which would equal 0. Cancel the root 3's. So 4 equals 3x, x equals 4 over 3. So the area, by plugging that back in, would be equal to root 3 into 4 over 3 into 8 minus 4 is 4, which is 16 root 3 over 3, which is D. Next. Okay. Dy dx. Let me first, so let's find the coefficient of x to the 4. No, okay, I'm going to differentiate this straight up. So dy dx on that is going to be 18 into 2 plus 3x to the 5 using the chain rule. And let's find the coefficient of x cubed. So it's going to be 18 into 5, choose 3, 2 squared, 3x cubed. So it's going to be 18 times 1, 1, 5, 10, 10, 5, 1 from Pascal's triangle times 4 times 27. So it's going to end in a 0. That's going to end in an 8 times a 6. So it should be a 6. Hold on, let's... How am I going to do this? So 10, 10, 10. So it's already bigger than 1,000. God damn it. 72 times 27 times 10. So 72 times 270. So that's already going to be bigger than 7,000. And it's going to end in a 4. So that looks like E. 8 times 8 is 64. Yes. Okay, cool. Geometric progression. First term equal to 1, common ratio that, sum to infinity. So A over 1 minus R is 4/3. So 3 equals 4 minus 2 sine 2x. So 2 sine 2x is equal to 1. So sine 2x is a half. And as we saw earlier, 1, 2 root 3. That makes that... don't make me work in radians. I know, I don't like radians. So it means that 2x is equal to pi over 6 or 5 pi over 6. But we want in the range from 2 pi to 4 pi on 2x. So let me add 2 pi to that to give 7 pi over 6 and 11 pi over 6. And 2x. No, not 11 pi. I wanted to add 2 pi to that, so I needed to add 12 to that to make that 17. And again, I needed to add 2 pi to that, so that should have been 12 on that, which makes 13. So when I divide those both by 2, I get 13 pi over 12 and 17 pi over 12. Which then gets me up to 2 pi. All right, so that's A. Okay. Next, 47. Okay, so these are the numbers. So U1 is 2. U2 is 2 multiplied by P, add 3. U3 is multiplied by P, add 3. U4 is minus 7 is multiplied by P, add 3. So this means that 2p cubed plus 3p squared plus 3p, add that across, plus 10 is 0. So if I'm going to find a p, it's going to have to be negative. So minus 1 doesn't work. Minus 2 would be minus 16 plus 12 minus 6 plus 10, which does work. So minus 2. So I can take a p plus 2 out because minus 2 is a factor. And you're left with 2p squared. No, yes, 2p squared. That's plus 4. So minus a p, minus 2p plus 5. And on here, b squared is 1 minus 4. Okay, this has no solution. So p is equal to minus 2. Okay, let's go back up. So if p equals minus 2, then it's 2 minus 2. So minus 4 plus 3 is minus 1. This becomes 4 is 8 minus 6 plus 3 is 11 minus 6 is 5 and minus 7. So minus 8. So 7 minus 8 is minus 1, which is C. Answer. Next. Okay, so here, find the complete set. Okay, I'm going to use multiplying by x squared to make sure it's positive so this sign doesn't flip. I'll show you the other method later. So we are going to say here that x4 minus 6x cubed minus 9x minus 4x, that's meant to be squared, bigger than 0. So x into x cubed minus 6x squared, 9x minus 4, bigger than 0, x into, does 1 work? 1 works. So x minus 1 into x squared minus 5x plus 4, which is x into x minus 1 into x minus 4 into x minus 1, bigger than 0. So that's x minus 1 squared. So the roots are 0 and x, a double root at x equals 1, and then another root at x equals 4. We want this thing to be strictly bigger than 0, which is when x is less than 0, when x is bigger than 4. X is less than 0, x bigger than 4, which is A. Next. Okay, so 51. The curve y equals sine x is stretched by a scale factor of 1/2 parallel to the x-axis. Okay, so we're taking 1/2 of that and then translated by, so then we're moving it minus 4 pi, and we're going to call that x. Let's make x dash the subject. So 1/2 x dash is equal to x plus pi over 4. X dash is equal to 2x plus pi over 2, which is what goes inside the function. 2x plus pi over 2 is h, so I'm going to lock that in. Let's go. I'll explain that later. Here, 53. Two straight lines are that and that, where p is a real constant. For certain values of p, they're perpendicular, so the gradients are negative reciprocals. So 2p squared minus p is equal to minus 1 over p minus 2. So we're going to get another cubic. They are liking the cubics in this run, aren't they? Minus 4p squared. I'll just do it. Minus p squared plus 2p equals minus 1. So 2p cubed minus 5p squared plus 2p plus 1 is 0. Does 1 work? 1 works. So p minus 1 into 2p squared minus another 3p minus a 1, 0. So p minus 1, 2p, p. That would be, does that, hold on, b squared is 9 minus 4. Yeah, there are 2 solutions. Oh, no, closest to the greatest such value. Okay, so we're gonna have to actually do the formula on that. Apologies, I did not check how long I have. So here, b minus b plus or minus square root b squared plus 4 c all over 2a. That's definitely going to be bigger than 1. So which is the biggest value of p? It's going to be 3 plus root 17 over 4 is approximately equal to 3 plus root 16 over 4. Come on, Miro, you can do it. You can do it. I believe in you. So which is approximately 7 over 4, which is 1.75, which is b. Okay. Lock that in. And a test. Done. All right, so that was 17 minutes and 57. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 questions. Is that right? Yes. Okay, good. What should 13 questions have been? I really should have checked that out from the start. So I had 19 and a half minutes. I got it done in 18 minutes, so I had 90 seconds spare, so that was good. Okay, right. Let me catch up with what's been happening in the chat. I've been seeing it going. I'm like, no, FOMO. My God, you guys have been chatting. Hold on. Okay, hold on. First things first. I'm gonna have to mark this up. I wanna see how I did, and then we'll get there. All right. So starting with 29, 29E. Yep. 31C. Yep. 33B. B, yep. 35C, yep. 37F, okay. 39D, yep. 41D, yep. 43E, okay. 45A, 47C, 49A, 51H, 53B. Great. All right. Love to see it. Okay, let me go through, add some more. In fact, no. Let's catch up with the chat, if that's even possible. Love to see y'all chatting though. Where have I got up to? Yeah, square the first, square the last, and twice the middle too. Do you think doing PAT questions again is worth it for ESAT? Not really, because the PAT questions are designed to be a little bit harder and to be like worth 3 minutes worth of work. So maybe some of the earlier PAT questions, some of the earlier ones, like, could be helpful. Yeah, you're answering each other's questions, which is good. Might just have to GCSE now. That AS paper is quite right. People chatting. I agree that Solomon Press papers C1 would be a good one. So those are AS papers from back in the day when math was modular. So C1 and maybe even C2 would be good. But you're quite right. Finding some old C1 papers from back in the day could be good. From 39. In fact, yeah, there's some comment on how I could have done it faster. Okay, let's see if there's anything else. Do you know if Oxbridge look at contextual factors and stuff? They might do. It's a bit of a black box. They can kind of like assess candidates against each other kind of however they like, and you don't necessarily get a look in on that. They can do. They might not do. I would say, let me put it this way, they're going to make a fair assessment. You shouldn't worry about being discriminated against or disadvantaged in some way because of something that's outside of your control. Super random question. But by chance is your, nope, that's not for me. Okay, so much more commenting. Go on, ignore us. Y'all are just chatting. All right, but there is one comment here about how I could have done one of the questions better, so I'll make sure to get into that. So let's add some clarity and see if I could have done better. Right, so going back to the start of this and sharing my screen again, let's see if there's anything I need to explain a bit more detailed. I really liked what I spotted there in question 29. ESAT is full of these little tips and little tricks. So taking a factor of 2 out right away makes your life so much easier in the simplification, because then when you rationalize it, it ends up looking like a lot easier. So it just ends up becoming 12 plus 6 root 3 over 6, which simplifies very easily. Then you square that, sorted. Question 31. I think this is just simple trig, just making sure you're okay with your cast diagrams. Nothing too outrageous here. Question 33. Again, nothing too bad as long as you spot your self-quadratic and you're good with your power laws. 35. Again, I think that was pretty self-explanatory. Like, I think nothing I need to go into too much there. 37, again, power laws, log laws, not too bad. 39, there was a chat that I could have done that faster. It's much faster to write out. Oh, Oh, okay, okay, okay. I like that technique. So if you're comfortable um, using this, so if we know that okay, so we know this is a root of the discrete. So we differentiated. And we know when that equals 0, a root of that is x equals 2, and a root of that is x equals 4. So someone in the chat commented that what you can do is, if you know that's a root from factor theorem, we know that x minus 2 must be a factor. And we know that x minus 4 must be a factor of the derivative. It must have some constant in front, which has to be 3. So then this, when you expand it out, must equal this. So it's 3 into x squared minus 6x plus 8. So it's 3x squared minus 18x plus 24, which immediately means that p equals minus 9 and q equals 24. Wow, that was fast. Nice catch. Nice catch. I haven't used that before. So yeah, if you've got a cubic and you know the x coordinates of both turning points, that means you know the factors of the derivative. That's clever. I like that. Thanks for bringing that to my attention. And you're right, that would have saved a lot of seconds. I'll try and put that into effect next time. But yeah, otherwise, the normal solution path still gets you there, as I showed. Here, nothing too bad. Differentiate, set to 0, solve for x, plug it back in, find your area. So I feel like this is quite a good run. I'll show you the other path here for 43. So I chose to differentiate first using the chain rule, bringing the 6 down and bringing that 3. So this is ax plus b form. A comes out the front, so it's 3 times 6 to give me the 18, power down to 5. And from here, it was using binomial expansion, using Pascal's triangle to get 5 choose 3 rather than using the factorial method without a calculator. So that's all fine. And then from here, by the way, I use this in the math one as well. But for here, finding a way to do it without actually calculating it, because that's just like not fun to calculate. So to look at that and go, all right, let me get close enough. So I went 4 times 18 is 72 times the 270. Went, okay, what is it bigger than? Well, it's certainly bigger than 14,000. Oh, in fact, I could have got it just from that. 70 times 200 is already 14,000, so it had to be bigger than D. Let's see what's happening in the chat. I don't know what's happening. Ignore us again. All right, cool. Thank you. You just let me keep me posted. All right. Chat away. Let me know if I need to see something. I should probably come up with a system for like, no, hey, Patrick, this is actually for you. Because yeah, sometimes y'all chat to each other and sometimes you're chatting to me. Also, do you know what? This is genuinely, the fact that I say y'all on stream is 100% Emily D. Baker's fault. Like, I do not really say this in day-to-day life, but like, it is something she says on stream. So when I stream, I say it because she's like in my head is like how to do a stream. It's all right. We take our influences where we can get them. So here, it was just making sure I looked at the range, and that's on 2x. So 2x to 4x, and then making sure I get all the solutions in that interval and then divide through. So for 45, yes. Sounds like something's incoming for how to do this a bit faster. You could also graph it if you prefer that to graph. So you can save a few seconds if you flip it before. I see what you mean. So what you're talking about is it kind of, I suppose instead of cross multiplying, you could just flip, like take the reciprocal of both right away and say something like 1. So I'm guessing what you mean is saying 1 minus a half sine 2x is just equal to 3/4. And so when you bring that across, a quarter is equal to half sine 2x. And so sine 2x equals a half. That's just another way you could have got there. Take the reciprocal of both sides. Yeah. But once you get to sine of 2x equals a half, I like cast diagrams. Some people like using the graphs. So if you were using the graph, there's one complete cycle every pi. So the next cycle, we're looking for, oh no, sine was equal to a half, wasn't it? Apologies, positive a half. That would have been here. So we're looking for, hold on, let me get the eraser. So if that is our x-axis and this is our y-axis and this is a half, that is pi and that is 2 pi. So we are looking for these two solutions. And we know that this would have been pi over 6. It is now pi over 12. So it's going to be pi plus pi over 12 to give me 13 pi over 12. And 3 pi over 2 minus pi over 12, which will give me the 17 pi over 12. And so that's how you could do it from graphs if that's your preference. 47, you just do it. Now there's a lot of this. So to solve for cubics, it's trying out different factors and thus sort of fully factorizing it. I highly recommend, well, one of two things. Well, actually, two things. Do both. First of all, these are all positive. So the only way to make this come to 0 is if p is negative. So that's why I went straight for -1 or -2. Now, once you do that, knowing how to fully factorize without doing the algebraic long division is so much easier. So here, I use an inspection method. Someone's saying for 47, I would recommend looking into synthetic division. Oh, it's a very fast method of polynomial division. I kind of skip that entirely and just do inspection. But you're right that synthetic division is available. It's not a technique I was ever taught, so I could read up on that. I do have a textbook which contains it, and I can learn that. But I just do it by inspection. So let me teach you how I'm doing that. So I'm targeting 2p cubed plus 3p squared plus 3p plus 10. And I know I've got a p plus 2 out of that. So this is kind of like synthetic division. So you got to think, what would I need to multiply the p by to get to 2p cubed? I would need to multiply by 2p squared. But when I multiply the 2 by the 2p squared, that would give me 4p squared, but I only need 3p squareds. So I need to take off a p squared. How do I do that? Minus p on this p would give me the minus p squared that I need. Then I look at the 2 and the minus p, which would give me minus 2p, but I need plus 3p. So I need plus 5p on that. So I need a plus 5 at the end, which is good to multiply with the 2 to give you the plus 10. Like, inspection is so good. So practicing by inspection, yeah. And if you want to practice that skill in isolation, go to your textbook where you learned about algebraic long division and see if you can just do them by inspection. So you can see I did that a couple of times. So I even did it in the next part. So I'll show you again how I did that. So on 49, now I'll do this the alternative way as well, but for the method I did, you know that if you multiply by a negative number, you would flip the sign. So I can't multiply by x because it's sometimes positive, sometimes negative. So what I'd have to do here in order to keep the sign the same is multiply by a positive number, and x squared is the positive number. So when I multiply by x squared on both sides, this obviously just stays 0, but then this is times x squared. That cancels down, and it's just x times this, which in fact I should have just done. It would have saved me some seconds. But then let's look at what I did for x cubed minus 6x squared plus 9x minus 4. For polynomial division, you can also use synthetic. You can use synthetic, absolutely. I go for inspection, which I find personally a bit faster. Because I looked at that, I plugged in x equals 1, and I get plus 10 minus 10 equals 0. So x minus 1 is a factor. From this point, what do I need to get x cubed? I need to get x squared from that. but then that gives me minus x, and I need to get down to minus 6x squared, so I need another 5x squareds, which I get from there. Then I'm left with plus 5x, and I need another plus 4x's to get there, and then the minus 1 and the plus 4 gets me there. Inspection can be faster than synthetic if you train it, absolutely. So for me, inspection, I've just gotten so used to it now. And that gave me my next minus 1 x plus 4. So try the inspection method, see if you like it. From there, it was graph sketching, goes through 0. There's a repeated root at 1, so it has a turning point there and goes back down, comes back up, crosses at 4. So that gave me this. By the way, if you didn't like that method, you could use the two cases method. So the case where x is positive and the case where x is negative. And then multiply by x. So when x is positive, multiplying by x does not change the sign. And you've got this. Where again, that is x minus 1 squared, x minus 4. Bigger than 0, you would sketch that out. And so x would have a repeated root here. And when is x bigger than 0? When x is bigger than 4. And when x is less than 0, then the sign would flip. So we would have x cubed minus 6x squared plus 9x minus 4 would be less than 0. And so on face value, that would be everywhere at less than 4. But this is only true this case when x is less than 0. And it is true everywhere where x is less than 0. So it is all of when x is less than 0 and when x is bigger than 4 in the positive case. So that's another way you could have got there. Two cases is way longer for no reason. I quite agree, but some people prefer it. And it is a valid method, so it's worth pointing out. If it's what comes to mind and it's what you're comfortable with, have at it. I much prefer multiplying by x squared to keep the sign the same, and then you only have to solve one inequality. Some people don't like multiplying. Do you think it's worth doing ENGAA physics questions? Yes, I do. The ENGAA physics questions are the same as the NSAA physics questions. If you're thinking about the advanced physics questions, like this one, it can be helpful. It'll just sort of stretch. Yeah, in the advanced section, it'll stretch your physics, certainly. I would say it's not required. At this stage, though, if you're able to smash these questions, you're just going to feel more confident about the physics in section 1. So anything you can do to give you confidence, I think, is a good thing. Right, so is there anything else I need to cover? Yes, I really need to show you how I did this. You've been doing ENGAA paper 2s? Great, you're overtraining. Nothing wrong with that. So this is multiple x transformations. So here's how I make sense of multiple x transformations. So here, what I do to understand, let's take A, for example. What does that look like? What I do is I take the thing in the bracket and I set it equal to a new thing I call x dash, and then I make x the subject of the formula. So x is equal to x dash plus pi over 4, and then multiply by 2. So what this means is x dash is the original. So what this would do is it would take your original, multiply by, stretch it by 2 in the x direction, and then shift it pi over 2 in the positive x direction. Which is exactly wrong for this. And so what I did was I took the same thing but worked it in reverse. Well, if x dash is the original and x is the argument that goes into your sine function, then I said, well, what happens to the original? It gets stretched by a scale factor of 1/2, so the original becomes a 1/2 x, and then minus pi over 4, and that equals x. And I rearranged to find x dash, which gave me this thing, and that's what goes into the function. So showing you how that works here. Oh, apologies. Yeah, that cold is coming through. It's coming through. It's come get me. Now I'm going to resist it. Resist it with everything I got. So that guy, okay, let's set x that guy equal to x dash then. So 2x plus pi over 2 equals x dash. Let's make x the subject of the formula. 2x equals x dash minus pi over 2. Divide by 2, so you get x dash over 2 minus pi over 4. So you stretch it by a factor of a half and then translate it x over 4 in the negative direction. This for me is my absolute like life jacket when it comes to multiple x transformations. Argument equals x dash, where x dash is the original. Rearrange for x to work out what this function actually does. And if you're starting with transformations, apply those to x dash, make x the subject, and then that's what goes in the function. Ah, my cousin is in the chat. You got me sick. Well, you or Caitlin got me sick. or are getting me sick. Hope you're feeling better now, given that you are currently sick with the sickness I am getting sick with. 53. What happened here? Was there anything too rambunctious here? No, just that approximation that root 17 is approximately root 16. I like that I took the discriminant there just to make sure I was going to get 2 solutions. Yeah. Yeah, what? It's all right. We can blame Caitlin. All right, so that was it for that paper. Right, I've just got the physics to do. The NSAAs always take so much longer just because you got to get through 3 of them. All right, it's physics time. All right, chat, I'm going to ignore you for a bit. Feel free to chat to each other. If you really want me to read something, can you just like let me know like at the start of the comment? Because otherwise I'm just going to ignore it. Physics on the clock. 18 questions again. 18 times 1.5 means I should have 27 minutes on the clock, and I'll keep that in mind. So let's reset. And let's start the time. So 19, we got a car on a horizontal road. That's the velocity time graph. During this part of the journey, what is the total distance the car travels while it is, what is the distance that it travels while it is decelerating? So that's the area of this trapezium, which is the average of the parallel sides, which is going to be 25 times the distance in between of 20, which is obviously 500 meters, which is B. Great. Next. So 20. Saucepan of water is heated from below. Convection currents form and transfer heat through the liquid. The mass does not increase. The density of a fixed amount of the water decreases as it is heated. That is correct. The density decreases as it expands, and the volume increases. So it expands, and the density goes down. So 2 and 3 are correct, so that is G. 21. I've gotten this wrong before, and I'm not going to get this wrong today. Not the specific question, but questions like this. Different types of wave in air. Waves 1 to 3 are longitudinal. So that 1 to 3 are sound, 4 to 6 are electromagnetic. Only 2 of these unaided, just using their eyes and ears. All right, so I'm going to have to work out wavelengths. So I know that this is in the nanometer range, which is what you can see. So 4 is in, certainly. Now, what about sound? 300, so wavelength, so frequency is speed over wavelength. So speed over, let's take the one in the middle, 10 to the minus 2 would be equal to 330,000 kilohertz. Human hearing is 20 hertz to 20 kilohertz. That's not it. I think the 1 would have added a 0, so would have been, so it's 3 and 4, which is E. Okay. My splits are definitely off now because I went too quickly. That's not a bad problem to have. So 22. Charge of 60 coulombs passes through an electrical component. Steady voltage of that. Supply for 30 seconds. Resistance remains constant. What is the resistance? Charge passes. So current is charge per time. So 60 coulombs in 30 seconds is 2 amps. And V equals IR. 10 volts is equal to 2 RR equals 5, which is E. Okay. God, I love a good quick physics question. So 23. So broken down cars pulled up. That's the mass lifted through that. So I can tell energy from that. So the energy, mg delta H, so that's 12 kilojoules. Total energy input is that. Input to the motor is 75% efficient. Energy is lost from the motor and from other causes. What's the total energy lost? Oh god, I can tell him. So is it... Hold on, what's 75%? So that's 3/4 of that would be 21. No, so we get this much out. So energy lost is that minus that. It should be 16 kilojoules, which is D. I hope I'm not oversimplifying that. I'm falling for some sort of trap. 24. Once I have a medical scanner, source pairs, gamma rays. Detectors on each side of the patient detect the gamma rays. The distance between the two detectors is 3 meters. When the source is at Q halfway in between, they arrive at the same time. In a particular scan, they arrive at the time difference. This is the gamma ray source. So there, let's call that X. So that's 1.5 minus X. This is 1.5 plus X. And it's gamma. So distance equals speed times time. Time equals distance over speed. The speed is the speed of light in both cases. So the change in time would be equal to the change in distance over the constant speed, which is 2x over the speed of light. So 4 times 10 to the minus 10 is 2x over 3 times 10 to the 8. Cancel that down for 2 and 1. So 6 times 10 to the minus 2 equals x. 6 centimeters is d. Again, I'm not feeling confident on these for some reason. We'll see if I've done anything wrong. So 25. Plutonium-239 absorbs a neutron and undergoes fission. Which equation is correct? Well, the numbers on the top equals, so 240 equals W plus Y plus Z. And the numbers on the bottom add up, which means that 94 is 54 plus X. So which one of these rearranged correctly? Not A. Z does. B does, so I'm going to go with that. Great. Here, okay, electric motor is connected by constant 12 volts. Motor is used to lift a mass of 20 kilograms. 6 meters in time of 5. So the energy is mg delta. So mg delta H. So 1200 joules in 5 seconds. That many watts of output, which is 80% efficient. And that is 80% of 300 watts in. And so that 300, P equals IV. So it's 12I. So divide that by 12. We'll divide them both by 3. And so I equals 25, which is F. Just go for it. Just go for it. I'm second guessing myself. 27 decays into the stable nuclide Y. During this process, 4 particles are emitted, alpha and 3 beta. It's not a nuclide can be formed at any stage. Well, if you've got that, this can only be done by betas, which would only make the atomic number go up. So A can't be done. No shot. If the mass stays the same, you can't have any alphas. And so the atomic number can only go up, and so A is just not possible. The end. I'm literally not even going to look at the others. I know that's bad exam technique, but screw it. Let's see. Atom versus nucleus. Nice. Well, let's assume that so density is mass over volume, but the mass is the same because we're going to assume the electrons have basically no mass. So P1V1 equals density to volume 2. And the radius is that many times bigger. Well, the volume is proportional to the radius cubed. So it means that P1R1 cubed equals P2R2 cubed, canceling the coefficients of proportionality. So rho atom over rho nucleus equals rho R nucleus over R atom cubed, which is 1 over 3 times 10 to the 4 cubed. So it's 3 times 10 to the 4 all to the minus 3, which is A. Should be better at tactical skips. I'm not doing that, and that's a bad habit to get into. 29. Displacement of one of the particles varies with time. So that's with time, that's with distance. So speed. So V equals F lambda. Frequency is 1 over the time period. There are 1.5 time periods making up T2 minus T1. So the time period, which is 3 over 2. So the time period is 2/3 of T2 minus T1. And from here, the wavelength is double x2 minus x1. So this is 2 into x2 minus x1 all over the time period, which is 2/3 of T2 minus T1. Multiply top and bottom by 3 and divide by 2. 3 would cancel that, divide by 2. Yeah. So 3 into, I think the answer is E. Okay, 30. Shouldn't worry with the formatting so much. 30. Kettle designed to work from a car's power socket. A kettle has a power rating 150 watts. When a constant voltage of 12 volts is applied, so we can work out the current. How much charge passes through 20 minutes? That's fine. So P equals IV. So I is power over voltage. Divided all by 3. 50 over 4, which is 12.5 amps. Well, let's just call it 25 over 2. So that's the current, which is charge over time. So how much charge passes in 20 minutes? So it's 25 over 2 times 20 minutes times 60 seconds in a minute. Cancels for 10. Let's move a factor of 4 across there to make that 100. Then it is 15,000 coulombs, which is C. I'm going to go through my arithmetic on that because that was quite fun. I think I forgot to take a split on the previous one. 31. Freight train traveling on horizontal track at 2 collides with the passenger train at that in the opposite direction. Both trains immediately come to a complete stop, so it's okay. Inelastic, the freight train has 3 locomotives, thingy each, and 7 container wagons, thingy each. God damn it. All right, so what that means, if they both come to an immediate stop, the momentum after is 0. So the total momentum before was 0. So thingy... no, stop it. All right, so thingy moving at 2 had the same momentum as thingy moving in the opposite direction at 5. So this had a mass of like 2m and this had a mass of like 5m. So that was the mass ratio is 5 to 2. So the freight to passenger. So in terms of mass, the freight to passenger had a mass ratio of 5 to 2. Cool. Now the freight train has 3 locomotives. So the freight train was actually 3 locomotives of 130. So that was 390 and 7 lots of that. So it was actually 600 tons, which means if you divide that by 5, you get 120. So the passenger train had 240 tons, and which was 2 locomotives of 70, which took up 140. So there's 100 left, and a number of passenger trains of 10 tons each. So that's C to make it up to 100. Cool. Consider the 4 calculations. Which 2 calculations result in 40 kilograms? Well, immediately 3 does not have the right units. F equals MA. So for 4, F equals MA, M equals F over A. And that does give me 40 kilograms. So 4 is in and 3 is out. So if 4 is in, we're deciding, but it's not 3. So the answer actually must be C just from that. Done. Great. Love that. 33. No. All right. Let me be good. Let me check that. Let me check that one works. Kilogram meters per second. Yeah, that's just trivially true. Okay, cool. Parachutist falling at a constant velocity. Constant velocity means forces are balanced, no acceleration. A constant kinetic energy. Well, K equals half times M times half mv squared. So it's a half times 72 times 25. Let's take a factor of, well, let's divide that. So that's 36 times 25. Take a factor of 4, move it there. So it's 9 times 100. So 1 is wrong. Parachutist is losing GP at a rate of that. So mg losing 5 meters in 1 second. So that much energy in 1 second. So let's take a factor of, so that's 36 times 10 times 10. So that 2 is correct. And air resistance and the force of gravity are not a Newton's third law pair because they aren't. I'll explain why later. So only 2 is correct, and that is C. Here, 2 radioactive isotopes. Okay, so 34. 2 radioactive isotopes, X, Y, have those half-lives. They both decay 6 hours ago. Okay, so 6 hours ago. So X to Y. And both of the products decay. Product of the decay of both sorts is C. So before, so 6 hours ago, it was 1 to 1 to 0. Now, after 6 hours, that is 2 half-lives of X, which means it's gone down to a quarter. It is 3 half-lives of Y, which means it's gone down to an eighth. And all of the remainder that should have made up to 2 goes into Z. So that's 2 eighths. So 3 eighths remaining. So 5 eighths plus another. So 5 eighths. So 13 eighths have gone into here. So 2 eighths. And that makes up 6 eighths. So it's 2, which is good. Great. What fraction is now made up of Z? 13 out of the, that much out of the total of 2 is 13 out of 16, which is D. Great. Next. So 35. You can do, I tell I've been doing too much TMUA. My math is good and my physics feels off. Car X passes car Y on the motorway. It's traveling 1.5 times the speed. The mass is that. Kinetic energies. All right, so let's consider Y. So Y is half mv squared, and we're going to, so that's equals Y. And then for x, we have a half times m times v squared, which is 9/4 v squared. That 4 cancels that 4. It becomes 9/10 mv squared is x. So 2y is mv squared. So x is equal to 9/10 of 2y, which is 9/5, which is 1.8y, which is e. Okay. 36. Okay, so we got a circuit. Ammeter reading is 4 amps. Power dissipated is 12. So P equals I squared R. So the current in there is 1. So the current in there is 3. And P equals I squared R. So it's 3 squared is 9 times 4 is 36, which is E. Great. Love me a circuits question. Oh, and we're done. Oh, that was way too fast. Didn't I have 27 minutes? All right. Well, that was done in like 19 minutes and 15 seconds. Love to see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Answers submitted. They're all there. So that was done in 1920. Am I right? Yeah, I should have had 20 minutes. Feeling good about that. To be honest, let's be real. In proper exam technique, I should have gone back and checked, but like, whatever, sue me. This feels more like a practice run, but let's just sort of see how I did. So 19 is B, good. 20G, 21E, 22E, 23D, 24D, 25B, 26F, 27A, 28A, 29E, 30C, 31C, 32C, 33C, 34D, 35E, 36E. Bam! Another full marks run. All in a day's work. It does feel good. That felt good. Getting it right that quickly. It's also good because it means there's less for me to explain, which is also helpful. I can kind of just go through, explain in a bit more detail where I took to now this. Yeah. Let's talk about this. So what I did here, reason why I did that so fast, I knew when it was decelerating, I was going to get just the area under this part of the curve. I knew that was going to be the area of a trapezium, which I know is the distance in between, which is 20, times the average of the parallel sides. But I didn't even look at the 30 and the 20 and average them to get 25. I knew because it was linearly reducing between them, the value halfway through was going to be the average. So I just went, bam, 25. So I said it was, just 25 times 20 because of that. So that saved me some seconds, which was quite fun. And then from here, because this is the whole point of convection currents. When you heat it up, it expands and become less dense, which is why it rises. So it does expand, so the volume does increase, and in doing so, it becomes less dense. The volume does the density does decrease. The mass stays the same. Nothing too complicated. Here, I save some seconds by knowing the wavelength range of visible light as being 400 nanometers to 700 nanometers, and I knew that 4 was just in the right zone. Now, for the other one, I didn't know the wavelengths of sound that you can hear, but I did know the range of human hearing was like 20 hertz to 20 kilohertz. And so I just found any one of those frequencies. I found the one in the middle. The one in the middle was too high, so I needed a smaller frequency, so a longer wavelength. So that was 3. Just using the wave equation to get there. So that was fine. Here, self-explanatory. Get the current, get the resistance, great. Here, okay, I wasn't overcomplicating it. because it was really tempting to say, oh, so efficiency. Okay, let's do this the long way. So efficiency. Hold on, we got a question. In most ENGAA papers, I write out all my working in terms of variables, then sub all of it in after. I think it's a habit picked up from Bifo and Pat, where you don't really use numbers. What are my thoughts on that? First of all, my thoughts are that is phenomenal technique for an interview. Not necessarily the best when it comes to ESAT. It's really up to you. Like ESAT is 100% nonstop go. So if you are still doing ESAT, then I would say do whatever works best. If you are prepping to sort of go into university and beyond, that is best practice, working in variables and only substituting right at the end. You've got someone has got an ESAT on January 8th, solved every past paper for the NSAA with 80% efficiency under time conditions. Is that enough? Yes. So you should be aiming for 70% as like a good mark. So 80%, very good. That's on track. Feel good about that. Right. Let's look back at this. 23. Okay, so I could have done this, ironically, the less efficient way. So if this input, because remember, efficiency is useful output over total input. So if there's an input of 28, then the useful output should have been 21 kilojoules. But actually, only 12 kilojoules is used up. So 9 kilojoules is wasted there, and 7 kilojoules is wasted there, which also add up to 16. Or you could have just done it one step and gone 28 in, 12 out, so 16 wasted on the way, which is what I chose to do. 24, let me do this a bit more slowly. So distance is speed times time. Time is distance over speed. Some of the steps I skipped are that the change in time is t2 minus t1, which is d2 over v minus d1 over v. And the change in the distance is this 2x. So that's how I got to 2x over speed is equal to the change in time, which is this, and then rearrange that for x, and I got 6 centimeters, which was the distance from the middle. 25, numbers on top add, numbers on bottom add. Ooh, for 24, seen those questions a lot, and I instantly know that the change in distance is just the change in time multiplied by the speed. So yeah, because that is another way of thinking about it. Because distance equals speed times time, the change in distance is speed times the change in time. And that is useful, for instance, in when things reflect from a crack or reflect off two different surfaces and make it back in different time. That's a more common way that I've seen this question play out. I always like setting it up from first principles, though, just to make sure I'm not forgetting anything. Like if the change in distance is twice the distance I actually want to measure, right? So if that's an echo, then this delta D is twice the actual distance you want to calculate. So by defining my x, I know as soon as I solve for x, I'm actually done with the question. So that's why I choose to do that, to avoid thinking I'm done with the question when I'm actually not done with the question. But yeah, that totally works for you as long as you have systems in place to guard against that exam technique issue. So 25, add up the numbers on top, add up the numbers on bottom. 26. Yeah, here's the first is this where I used it? No, I haven't used it. I will show you this arithmetic stuff I did at some point, though, because I do like this skill. It's very useful in physics when you're dealing with lots of numbers. So I didn't use it here so much. Just got my GPE, divided by 5 to give me the power out. Compared that with the power in using this efficiency, backtracking. So 300 watts are in, which is IV. Yeah, so that got me my 25, nice and easy. Here, again, my argument, yeah, I just looked at the first one and I got lucky. It was just not possible. Just full stop the end. Atomic numbers only go up if the atomic mass stays the same, because that's what beta does. 28 was fun. I like I got in the habit of this dealing with like Boyle's law. So P1 V1 equals P2 V2 because P is inversely proportional to V, so you can rearrange them both to get the constant of proportionality. Here, density is inversely proportional to volume, and the constant of proportionality is M. So M is the constant. So rho 1 V1 equals rho 2 V2. Which is why I was then able to set a similar situation with rho r1 cubed equals rho r2 cubed, and then did it in terms of a and n instead. So this is similar. I just didn't want to have to deal with the constants and doing lots of calculation. So this is one instance where doing everything in terms of variables and substituting right at the end is actually helpful for saving time. 29, classic wave equation stuff. V equals lambda over time period, where you just read those off the table. Nothing too complicated there. 30. Yeah, okay, let me show you this because I like how non-calculator, I use some skills to simplify the computation, right? So let's look at it in slow motion at what I did at this step. So once I got that I was equal to 25 over 2, I said that Q was equal to I times T. So at this point, it was I chose to cancel the 2 with the 20 to make it 10, because that would just add a 0 at the end. Which neat trick? Are we talking about the neat trick to do with the proportionality, or are we talking about this neat computational trick? Sorry, I don't know. That's a delayed reaction. But here, look at what I did. I was like, okay, well, that's 25. This one, yeah. This is a 25. I went, I can't be bothered to multiply that out. Let me just take a factor of 4 from here and distribute it onto here. So if I take a 4 and distribute it across, I'm left with 100 and 10 and 15. And then bam, right there. So yeah, I definitely, that's helpful for me in the mental math. It just, yeah, you'll see me do that in all my ESAT runs. So I did that a few times in this run as well. Just redistribute the factors so they come nice. So I think I may have done, yeah, I've definitely done it somewhere else, and I'll point that out when I can. So here, 31. Yeah, I like how I did that. Find the mass ratio. Find the mass of the freight train. Use that ratio to find the mass of the passenger train and work backwards. I liked how I don't think I need to clarify too much. Here, 4 was the one that drew my eye. So it had, because it had the right units. Well, I started with 3 because that just had the wrong units and just couldn't work. Because you'd get something which was kilogram meters to the -6. Here, mass is force over area. That got me my 40 kilograms straight away. So I knew 4 was in and 3 was out, and that just meant the answer was C already. From that point, yeah, you can go back and clarify that the meters per seconds will cancel. You'll be left with 40 kilograms. That's great. I remember getting this wrong in practice for the trap in option 3. It is so tempting to look at that and think, oh yeah, those powers cancel. They do not. They do not, because it's divided, so you subtract the powers, it becomes -6. Also here for completeness, that's energy, that's distance. I think this is trying to get at work done is force times distance. Let's just no. No. Oh no, maybe that's trying to mg delta h it. I think that's what the trap is. I think it's saying energy is mg delta h. So mass is E over G delta H. But I think they're forgetting that G has units or something. Like, that just doesn't work. Doesn't work at all. Work equals force times distance. Yes, but then if you do like work done divided by distance, you get a force, not a kilogram. So I suppose maybe the unit's wrong. Yeah, it should have been 40 newtons. Probably. I was just trying to make it so it would actually give you something with kilograms. Either way, it's just wrong. Just so wrong. Here, let's have another look at how I did my factor distribution here to make my life easy. So to work out half mv squared, let's again do that in slow-mo. So I said it was a half times m times v squared. I canceled that with that to make 36. And then again, that would be convenient with an extra factor of 4. So take the 4 out of there, put it on there, it becomes 900. Bam, done. Super helpful for any non-calc situation. Same thing here. It's M, G, H over 1. And again, this would be convenient with an extra factor of 2. So then 3,600, done. So very much advocate for that on any sort of ESAT where you have to do quick math and not get it wrong. And they'll often leave it so that things either cancel very well or you can do that factor distribution very well. Also helpful with fractions, by the way. If you have something like a 37 over, like, I don't know, 25, multiply top and bottom by 4. So it's something over 100. Multiply that by 4. 8 to 4 to 148, so it becomes 1.48, done. So that can also help. Just turning things into powers of 10 is just helpful to make your math go easier. Cool. So this, I really advocate for this ratios idea when you're doing anything involving radioactive decay in ESAT. So get the ratio as it was before, and then get the ratio as it is after the decay. So doing this more in slow-mo. So it was in a 1 to 1 to 0. After 2 half-lives, so every half-life it goes to a half, then a half again, so it goes to a quarter. This goes to an eighth, and the remaining 13 eighths goes into Z, because that's what's left over to make you up to the same 2 that you had before. Or alternatively, I suppose there's another way you could have done this one, which is instead of doing it in this 1-to-1 ratio, you can consider what fraction it was to begin with. So if they were the same number to begin with, we started with a half x, a half y, and no z. So again, this way, after 2 half-lives, this would become a quarter of the original, so it's an eighth of it. This would become an eighth of the original, which is a 16th of it. And the remaining 13 16ths have to be z, which is how you could get there a bit quicker. I chose to leave it as 13 over 8 and divide it by 2, which had a little bit of more risk to it. I just didn't think to, I just saw 1-to-1 and went for it. But that was there. So if you think about what fractions they are at the start, and then apply the half-life formula, you can see what fraction of z is left at the end. I like how I did 35. So writing things in terms of the same stuff. I don't think there's anything much to say there. I just made mv squared 2y, so it was 9/10 of 2y, so it was 1.8y. Yeah, that was fine. I like 36. I didn't annotate because you can't do that in the real thing. But if we have a look here, P equals I squared R. So 12 equals I squared times 12. So I squared is 1. So this current is 1 amp. But if that's 4 amps, at here, current in equals current out. So 3 amps have to be going through here, which is where I got my P equals I squared R to apply here. So that's 3 squared is 9 times the 4, giving you 36 watts, which is E. And that was that. Right. I feel this is the longest live stream I've ever done because ESAT takes a while, and I've got people who ask me questions now, which I quite enjoy. Right. So that was an ESAT run. Full marks on that. Could have done better on my tactical skipping. I think there were a few moments where I could have just done better on that. But overall, for me, I could tell time was going well. The execution was coming out. Another full marks run out of the bag. So hopefully that gives you some tips and tricks and things that to improve your speed and accuracy when it comes to the ESAT. Now, like I say, keep a lookout. I'm going to populate the stream well in advance for when I'm going to do it. But sometime on the 3rd, I'm going to do a quick, maybe 1-hour stream going through any questions you have about the ESAT and how to prepare for it at this final stage, and going through different question types from different papers to show you the types of things that come up again and again, and the techniques you can use to make your life easier. So yeah, advice before, absolutely. So that'll be coming on Saturday. Advice before the day, yep. when is the because yeah, I'll be doing that stream on Saturday the 3rd, so that will be before the ESAT, so you don't have to worry about that. So that'll be coming, showing you any sort of tips and tricks like that, just distribution technique, and any little things I think that are helpful. And I've got now so many live streams of live solves of ESAT papers, so I'll probably go through those and just sort of point out like, oh, those were the good bits, not like actually showing you, but taking a little log. So yeah, Saturday the 3rd, which is well in time for the 6th or 7th, which will then also give me time to then pivot to the TMUA for next week, which is a little bit later in the week. So with that, keep an eye out for the 3rd. I think it's going to be around like 4 p.m. or 5 p.m., but like the stream will be populated days in advance, so you will know exactly when I go live. In the meantime, keep working hard on whatever you have left to go through before the ESAT. I hope you all have a good new year, and I shall see you guys on Saturday. All right, take care now. Bye-bye. You're very, very welcome. Take care.